Good morning, dear students. Today, we will discuss a new topic that is called pair of straight lines. Okay, and before I start, could you, a couple of you, please confirm that you are able to hear my voice very clearly?
Yes,
And
sir.
okay, okay.
Yes,
All right, good. And able to view the screen properly, also, right?
Yes,
yes,
sir.
Okay, great. So, what is a pair? Pair means two. That is why we define as pair. Pair of straight line means two straight lines. Okay. Now we are going to see that how we can jointly represent, the two straight lines. So let me first draw the coordinate axis. Okay. So suppose so as you see, this is the coordinate axis. Now suppose we have two straight lines, generic straight lines. I'm telling one straight line I'm drawing in, green color. Okay, this is one straight line, and another straight line what I am drawing in, suppose blue color, is another straight line. Suppose another straight line. Now these two straight lines jointly, how we can represent? Okay, what will be their equation? Joint equation. That means when you see these two straight lines, joint equation, if it is in a particular form, then you can say, oh, it is a joint representation of two straight lines. Okay, that we are going to discuss. That is called pair of straight lines. Now we are dividing this discussion into two parts. In the first part, what we'll discuss is that we'll discuss the pair of straight line, passing through origin. Today, what we'll discuss, the pair of straight line passing through origin. What does it mean? It means that the straight line what you see, if I make a little change here, so for example, first straight line is something like this, and second straight line which I'm going to draw in a blue color is something like this. Okay, if you see these two straight lines, their characteristics, one is in green color and another one is the in blue color. If you see, these two represents a pair of straight line passing through origin. So today we are going to first discuss this one, and in the next session we will discuss about the pair of straight line which not necessarily passing through origin. Now dear students, if I say that what is the general equation of a straight line passing through origin? Okay, general equation of a straight line passing through origin is generally y equal to mx, where m is the slope of that straight line, by this time. So suppose this straight line what you see in the green color, and if I write the equation also in the green color, so it will be something like y equal to m1x. Just a minute. So its equation should be y equal to m1x, and this equation, the other straight line what you see in the blue color, its equation should be something like y equal to m2x, where m1 and m2 are the slope of these two straight lines respectively. Now the point is that how jointly we can represent, means y equal to m1x and y equal to m2x, if we jointly represent, how it will look like. In one way you can say, sir, I can write something like this, that jointly if you want me to represent, then I will represent something like this: y equal y minus m1x into y minus m2x. Okay, so that you can say, but what we are going to discuss is that in a more generic form. Okay, And for that, first we need to understand a point called, or concept in equation called homogeneous equation. Okay, so first we need to know what is a homogeneous equation. You know, dear students, that homogeneous equations, okay, an equation whose right hand side is 0, okay, in which the sum of the powers of the unknowns, let's take two unknowns, x and y, okay. Let me first give you an example of a homogeneous equation. Suppose if I write 2x square plus 3xy plus 5y square is equal to 0 is a homogeneous equation. Let me first explain with an example, then I come to the exact definition. Why it is an homogeneous equation, dear students? Because the power of x, power of y, and power of x and y together in each of the term in the left hand side is 2 constant. Okay, then why called, it is called a homogeneous equation of degree 3 in x and y. So this is a homogeneous equation. This is an, we can write as a homogeneous equation. Homogeneous equation of second degree, we can write degree 2 or second degree, both are same. Second degree in x and y. So this is one thing. Suppose if I give another example of a homogeneous equation of third degree in x and y. So how it looks like, dear students? So it will be something like this. Suppose I write 5 into x cube plus 9 into x into y square plus 8 into y cube, that is equal to 0. Why? If you see each and every term in the left hand side, okay, the power of x is 3 or power of y is 3 and x and y together is 3. You see, in the second term, for example, it is 9xy square. What is the power of x and y together? It is 1 plus 2, that is 3. What is the power of x? That is the first term, 3. The third term, power of y, that is also 3. So this is, we can say from here that it is a homogeneous equation of degree 3 in x and y. So what we can write? That you can write the homogeneous equation of third degree in x and y. So now let us come to the formal definition, the way we define an equation. Okay, let me first place this one from the study material, and then we will discuss about it, and then you will see that how it is relevant with the pair of straight line passing through the origin. Okay, so here what we see is that if you look into the definition of the homogeneous equation, an equation whose right hand side is 0, in which the sum of the powers of x and y in every term is the same, say n, is called a homogeneous equation of degree n in x and y. Dear students, for the sake of our uh, you know simplicity, we are taking the two variables x and y, and that is also very in sync with our the context, because we are discussing straight lines in 2 dimensions. So x and y, two variables, are sufficient. For example, ax square plus 2hxy plus by square equal to 0 is a homogeneous equation of second degree in x and y. Then cx cube plus dxy square plus uy cube equal to 0 is a homogeneous equation of second degree, is third degree. Sorry, I wrote it here second degree by mistake. It is a third degree, in x and y. Okay, it should be third. Okay, dear students. So what we are going to discuss, as I was telling, is that we are going to discuss a pair of straight line passing through origin. That is our discussion at this moment. That what we are going to discuss is the pair of straight line passing through the origin. So that we should be discussing first, and let's see. Okay. So you know, now the first point what we are going to discuss is that a homogeneous equation of second degree of the form, a homogeneous equation of second degree of the form as we always see, that where the term of x and y always will be the fixed one. A homogeneous equation of second degree always represent a pair of straight line passing through the origin. So that means what? That means what we can say from this statement, if I write it down and show it to you and here from the study material, and then let me explain. It says something like this. A homogeneous equation of second degree, okay, uh, always represent a pair of straight line passing through the origin. And what is a homogeneous generic equation of a homogeneous equation of second degree? Is something like this: ax square plus 2hxy plus by square equal to 0. That is a homogeneous equation of second degree in x and y. So this jointly represent, as I was telling in the beginning, dear students, one way you can represent two straight lines passing through origin as y equal to m1x and y equal to m2x. Now, if you join this together, y equal to m1x and y equal to m2x together, then you will get an equation something like that. What you see, that ax square plus bx plus ax square plus 2hxy plus by square equal to 0. That jointly represent a pair of straight lines. Okay, that means what you can say is that you can say something like this, that if y equal to m1x and y equal to m2x be the equation of individual straight lines, so you can write something like this: ax square plus 2hxy plus by square is actually representing that y minus m1x into y minus m2x jointly, dear students. Okay. Now the next point what we're going to discuss is that we are seeing that yes, it is passing through the origin. Okay, but the next point is that there are some conditions, and based on those conditions we can conclude the nature of these straight lines. Okay. So the point is that, so what we see is that it represents a pair of straight lines. So let me remove this part at this moment. I just explain you that how algebraically it looks like. After that, what we are going to say is that that represents a pair of straight line, that whatever you see, ax square plus 2hxy plus by square equal to 0 represent a pair of straight line passing through the origin. Moreover, based on the following conditions, we can conclude the nature of the straight lines. So what is the condition? H square minus AB. What is 2h? 2h is the coefficient of xy, if you see in this from this equation. And a is the coefficient of x square and b is the coefficient of y square. So if h square minus ab is greater than 0, then we can say the straight lines are real and distinct. Okay. This means these two are different straight lines and and they are real. If h square minus ab is equal to 0, then we can say the straight lines are real and coincident. And if h square minus ab is less than 0, then the straight lines are imaginary. So dear students, out of these three cases, we are confined to the discussion on the first two. That means if we join these together, that h square minus ab greater than 0 and h square minus ab equal to 0, these jointly represent h square minus ab is greater than equal to 0. So we will discuss the pair of straight line when h square minus ab is greater than equal to 0 holds true. That will be the our discussion. Okay. Now let us bring back this topic that when if m1 and m2 be the slope of the pair of straight lines, as you see represented by the equation 1, which is the homogeneous equation of second degree in x and y, then the equation of the straight line must be of the form y equal to m1x and y equal to m2x. Correct? So then what you can write, as I was telling, that if we represent these two straight lines, that as y equal to m1x and y equal to m2x, so then what we are going to get? So what I'm saying is that you can represent these two as y equal to m1x and y equal to m2x. So if we jointly represent this thing, then we will find the relationship between these slopes and the coefficients of the terms of this homogeneous equation of second degree. So what we are going to get? So let's see it out. Okay. So ax square plus 2hxy plus by square, okay, plus by square, that you can as if represent as a factor of two terms, that is y minus m1x and y minus m2x. Correct or not, dear students? If you see from an algebraic point of view. So what we are going to get? We are going to get is that if we make this thing, that the uh, as if that you can make as a factor of these two. Now from these two, this relationship, we are going to find the relationship between the coefficients of the homogeneous equation of second degree, different terms coefficient, and that m1 and m2. And what is the relationship we are going to get, dear students? So we are going to get the relationship something like this. Okay. So, let m1 and m2 be the slopes of the pair of straight lines represented by the equation 1. Above equation 1 means we represent this as equation 1 here, as you see. This is equation 1. Okay, ax square plus 2hxy plus by square equal to 0. So if m1 and m2 are the slopes of the pair of straight line represented by this homogeneous equation of second degree in x and y, like x square plus 2hxy plus by square equal to 0, then the equation of the straight line should be of the form y equal to m1x and y equal to m2x. And eventually we will come to these two relationships. First one is that m1 plus m2 is equal to minus 2h by b, and m1 into m2 is equal to a by b. So and you can derive it by equating the, because this becomes an identity now. So as it is an identity, so you can find their that coefficient of the term, coefficient of x square, y square, and xy in the left hand side should be equal to the coefficient of x square, y square, and xy in the right hand side. From there you can easily conclude that these two relationship, m1 plus m2 is equal to minus 2h by b, and m1 and m2 is equal to a by b. So why these two relations are very important is that when that homogeneous equation of second degree is given to you, you have not been given the slope of the straight line represented by them. But as you know, the coefficients are given. As you know the homogeneous equation of second degree, you know their coefficients. From their coefficients, you can find the value of m1 and m2 also. How? Because you know m1 plus m2 is equal to minus 2h by b. and you also know m1 into m2 is equal to a by b. From there you can find the value of m1 minus m2 and eventually m1 and m2. Correct? So in this context, so these two relationships are very important. Okay. Now what we're going to discuss next is that what is the angle between the pair of straight lines. Okay. So if we discuss the angle between the pair of straight lines, and if we confine our discussion with the acute angle first, and then we'll go to the obtuse angle eventually. So think about the two straight lines having slopes m1 and m2. What will be the acute angle between them? We have discussed all these things earlier sessions, and it is available in that in the form of YouTube videos, both in the online platform and in the YouTube. Is that if theta be the acute angle between the pair of straight lines represented by ax square plus 2hxy plus by square equal to 0, that means eventually it is represented by y equal to m1x and y equal to m2x. Then what will be the theta? Let's find it out then. Okay. So let me first take that portion from the study material. Let me show it to you. After that, I will explain you exactly how it actually we derived something like this. So angle between the pair of straight lines. So dear students, whenever we see the homogeneous equation of second degree, something like ax square plus 2hxy plus by square equal to 0, that means it's jointly represent two straight lines, y equal to m1x and y equal to m2x, correct? Jointly they are representing something like this. Let theta be the acute angle between the pair of straight lines represented by ax square plus 2hxy plus by square equal to 0. The statement what I said can also be reframed as let theta be the acute angle between the pair of straight line represented by y equal to m1x and y equal to m2x. The moment we give value to the second statement, then we can write theta is equal to acute angle. Theta is the acute angle. So theta is equal to tan inverse of mod of m1 minus m2 by 1 plus m1 m2. Correct? That we know the angle between two straight lines with whose slopes are given. Now we are going to transform this from slopes to the coefficients of the the different terms of the homogeneous equation of second degree. That means theta become tan inverse of 2 into square root of h square minus ab divided by a plus b. So what is the angle between the two straight line represented by the homogeneous equation of second degree in x and y, like ax square plus 2hxy plus by square equal to 0 is tan inverse of 2 into square root of h square minus ab divided by a plus b. That is the acute angle between the two straight lines. That is a pair of straight lines. Now the moment we know the acute angle between them, then we can find eventually the obtuse angle. That should be pi minus that angle. Okay. So, and eventually the obtuse angle between the pair of straight lines, it should be pi minus, it will be tan inverse will be there here. So pi minus tan inverse of 2 I can write it here, just a minute properly. So it should be pi minus is pi minus tan inverse of 2 into square root of h square minus ab divided by a plus b. Now we are going to conclude, we are going to conclude few important things. Under what condition that these two pair of straight lines are perpendicular to each other? Okay, and for that we just don't need to go through the their slopes, because we are not aware of the slopes, as I am keep on repeating this statement, because we only know their joint representation by means of the homogeneous equation of second degree. So dear students, so it is to be noted that the pair of straight lines represented by ax square plus 2hxy plus by square equal to 0 will be coincident or parallel if h square minus ab is equal to 0. And that we can find theta should be 0, right? If they are coincide or parallel, that means the angle between these two straight lines is 0. If theta is equal to 0, then obviously the numerator of tan inverse, whatever you see, has to be 0. That means h square minus ab has to be 0. Correct or not? What is theta? We know acute angle. Theta is equal to tan inverse of, 2 into square root of h square minus ab divided by a plus b. Correct. So from here what we can write? 2 into square root of h square minus ab divided by a plus b is equal to tan theta. Now dear students, if theta is equal to 0, then tan theta is 0. Theta equal to 0 means what? They are parallel. That means tan theta is 0. If tan theta is 0, that means definitely 2 into h square minus ab is equal to 0. Parallel means what? Parallel implies theta is equal to 0. That implies what? Tan theta is equal to 0. That implies what? If tan theta is equal to that 0, that means 2 into square root of h square minus ab by a plus b is equal to 0. And that eventually says that this implies, if this is 0, that means h square minus ab, that is equal to 0. And that is what has been mentioned here, that h square minus ab is equal to 0 signifies that the pair of straight line represented by the homogeneous equation of second degree in x and y, that is ax square plus 2hxy plus by square equal to 0, are parallel. And when they will be perpendicular? Perpendicular means what, dear students? Perpendicular means that theta is 90 degree. Sorry, theta is 90 degree. By mistake I wrote 0 here, but theta is 90 degree. That implies what? Tan theta is equal to undefined, infinite. Now if that means what? That implies 2 into square root of h square minus ab by a plus b is equal to undefined. That means what? It definitely the denominator has to be 0, because we know something by 0 is undefined, and that is why this relation a plus b equal to 0. So in summary, what we can say, dear students, the pair of straight line represented by ax square plus 2hxy plus by square equal to 0 will be coincident or parallel if h square minus ab is equal to 0, and they will be perpendicular to each other if a plus b is equal to 0. I hope it is clear, dear students. The next point what I am going to discuss is about the bisectors of these straight lines. Okay, so how we can find the bisectors of the angle between the pair of straight lines represented by ax square plus 2hxy plus by square equal to 0. Okay. Now here I'm going to discuss this point. Let me first keep the study material, and then I will discuss. What is our joint representation of that pair of straight line passing through the origin is, as you see, it is ax square plus 2hxy plus by square equal to 0. Let y equal to m1x and y equal to m2x be the equation of the two straight lines represented by the pair of straight line ax square plus 2hxy plus by square equal to 0. Hence, m1, m2 are bound by the relationship, as we know that m1 plus m2 is equal to, as you see in these two above two equations, is that m1 plus m2 is equal to minus 2h by b, and m1 into m2 is equal to a by b. Right? So, from this, what we can write is that, just a minute. From here, what we can write, this implies m1 plus m2 is equal to minus 2, just a minute, minus 2h by b, and m1 into m2 is equal to a by b. I'm just keeping it from here, that m1 plus m2 is equal to minus 2h by b and m1 into m2 by a by b. That we can write. Now, the equation of the bisectors of the angle between the line y equal to m1x and y equal to m2x is what? Y minus m1x by square root of 1 plus m1 square is equal to y plus minus y minus m2x into 1 by square root of 1 plus m2 square. Let me repeat the statement once more. The bisectors, the equation of the bisectors of the angle between the straight lines y equal to m1x and y equal to m2x is y minus m1x by square root of 1 plus m1 square is equal to plus minus y minus m2x by square root of 1 plus m2 square. Now, in that equation, what you see in this, what I marked here in the red color, so that equation, if we apply the relationship between the slopes and the coefficients of the homogeneous equation, that is m1 plus m2 is equal to minus 2h by b, and m1 into m2 is equal to a by b, then we will find the equation of the joint equation of the bisectors are coming like this. As there are two bisectors, they can also represent a pair of straight line. Na? What does it mean? If I draw the coordinate axis first here, dear students, suppose these are the coordinate axis. This is x-axis, this is y-axis, this is x dash, this is y dash. And now, dear students, so let's represent a straight line. Suppose this is one straight line which is in green color, and that is another straight line which is in, sorry, both are passing to the origin. Correct, na, dear students? Now, what will be their bisectors? One will be acute angle bisectors, correct? And another one will be obtuse angle bisectors. So these are the bisectors, right? So now what you see in the purple color. Now these two bisectors also represent a pair of straight line passing through origin. So what will be their joint representation? So this is the equation. So as there are two bisectors, we can represent these two bisectors of the pair of straight lines ax square plus 2hxy plus by square equal to 0 by means of the following homogeneous equation as you see it here. This is the homogeneous equation of second degree in x and y representing the bisectors of the straight lines represented by ax square plus 2hxy plus by square equal to 0. Correct, dear students? Now, you may ask, sir, how to find that which one between them is an acute angle bisector and the obtuse angle bisector. We have discussed how to identify which one is acute angle bisector and which one is obtuse angle bisector in one of our previous sessions. You can look into the relevant video lectures as available both in YouTube and as well as in the online platform at the konaclasses.com. There you can look into it to find which one is the acute angle bisector and which one is the obtuse angle bisector. Now, dear students, what we are going to do, we are going to solve a couple of problems together. Okay, and by solving this problem, we will see that our whatever we have just learned is actually we are able to realize our learning through solving these couple of questions. The first question what I'm going to give is something like this. Is it is available, it is going to be available in the digital screen in another few seconds. And here goes the question. The question is that, if the lines px square minus qxy minus y square equal to 0 makes angle alpha and beta with the x-axis, then find the value of tan alpha plus beta. Okay, the point is that you know, if we see this these two equations jointly represented by the moment you see this equation px square minus qxy minus y square equal to 0, okay, you should actually resemble with the equation something like this, that ax square plus 2hxy plus by square equal to 0. If you resemble, then what you are going to get, dear students, a is equal to p, correct now? Then we are going to get 2h is equal to minus q, so that means h is equal to minus q by 2, and what we get, b is equal to minus 1. So why am I equating like this? So it will help you to you know uh, formulate the problems properly. Now this equation, that what you see, that px square minus qxy minus y square equal to 0, that is represented by a pair of straight lines something like this, what, y equal to m1x and y equal to m2x, we can write, because they're passing through the origin. So y equal to m1x and y equal to m2x. Now according to the question, as these lines makes an angle alpha and beta with the x-axis, then what we can say, obviously m1 is equal to tan alpha, correct or not, and m2 is equal to tan beta, correct. But what we need to find, we need to find the value of tan of alpha plus beta. So now how we can find tan of alpha plus beta? Dear students, if we apply that trigonometric formula, what we get, tan of alpha plus beta is equal to tan alpha plus tan beta by 1 minus tan alpha into tan beta. So what is the value of tan alpha? M1. So that is equal to M1 plus M2 divided by 1 minus M1 into M2. Now what is M1 plus M2? If you recall, dear students, the formula, M1 plus M2 is equal to minus 2h by b, correct? And M1 into M2 is equal to M1 into M2 is equal to a by b. So what is minus 2h by b? Minus 2h by b is nothing but, minus 2h become q by b, so it become actually minus q. And what is m1 into m2 is equal to a by b? That is actually equal to minus b. Now if these values, if these two values we are applying here, then what we are going to get? This is equal to m1 plus m2 is equal to minus q by 1 minus of minus b. That implies what? We are getting the value of tan of alpha plus beta is equal to minus q by 1 plus b. So the value of tan of alpha plus beta we get is that is equal to minus q divided by 1 plus b. Never hesitate to let me know if something is not clear. Correct? Now, the next point, next question actually, what we are going to discuss, something like this. So here is the question. Question is that if the pair of straight lines ax square plus 2hxy plus by square equal to 0 is rotated about the origin through 90 degree. Then find the equation of these straight lines in the new position. So let me give you a visual representation of this problem, dear students. Okay, so let me first draw the coordinate axis. Suppose the pair of straight lines. So let's draw it in the green and blue color respectively, dear students. So this is one straight line, and this is one straight line. Now both these straight lines, as you see, as shown in the green color and blue color, and also jointly represented by ax square plus 2hxy plus by square equal to 0, both of them rotated with an angle of 90 degree. That means what? That means the new position of the green one should be something like this. It is 90 degree with respect to its previous position. Correct? Then the blue line also, it is rotated because they are jointly rotated. That means that straight line should be something like this. Correct? No, it is not drawn very properly. It should be something like this after rotation. So now if we see that before rotation, this is the joint pair, right? It is before rotation. Before rotation. And what is their joint equation? Joint equation is that ax square plus 2hxy, sorry, just a minute. Their joint representation is that ax square plus 2hxy plus by square is equal to 0. After rotation, what happened is that we see this is the equation after rotation. That is after rotation. Question is that what is their joint representation after rotation? Before rotation is given ax square plus 2hxy plus by square equal to 0. Now when both the straight lines are rotated 90 degree, okay, about the origin, okay, then what will be their joint representation in the new position? Okay. Now the given equation, whatever is given, dear students, that ax square plus 2hxy plus by square, that means that is before rotation, is equal to 0. Suppose these represent a pair of straight lines, something like this, y equal to m1x and y equal to m2x, correct? If this is the case, then what we are going to find it out, as we know, that m1 plus m2 is equal to minus 2h by b, as we know the relationship, and m1 into m2 is equal to a by b. Now, dear students, that let's assume the slope of the new straight lines, okay, new pair of straight lines after their rotation become m1 dash and m2 dash. Okay, so here before rotation their slopes were m1 and m2. After rotation their slopes becomes m1 dash and m2 dash, correct? So then one relationship, though, we can find it out now. m1 into m1 dash should be equal to minus 1, because these two straight lines, the old position of the green line and the new position of the green line are perpendicular. slope of the old position of the green line is m1 and slope of the new position of green line is m1 dash. So m1 into m1 dash equal to -1. In the similar manner, we can find m2 into m2 dash is equal to -1. So from there, what we can find? We can find that uh, m1 dash is equal to -1 by m1 and m2 dash is equal to -1 by m2. Correct or not? So what will be their joint representation? So if we see their joint representation, dear students, okay, it should be something like this. Y equal to m1 dash into x and y equal to m2 dash into x. So then in algebraic form, what will be their joint representation then? Okay, so their joint representation should be, their joint representation should be y minus m1 dash x into y minus m2 dash x is equal to 0. Now m1 dash and m2 dash, the only way to proceed is that to express in the form of m1 minus m2. That implies what? That implies y minus m1 dash means equal to plus 1 by m1. So that implies y plus x by m1 into y plus x by m2, that is equal to 0. Correct, dear students? So then what we can write this thing in jointly we can write this implies that x plus m1y plus x m1y plus x into m2y plus x is equal to 0. That implies m1 into m2 into y square plus m1 plus m2 into xy, m1 plus m2 into xy plus x square is equal to 0. Now the value of m1 plus m2 and m1 m2 in terms of a, h and b are here as I just encircled. So let's apply those values from here. So what we are going to get then, if we apply those values, m1 m2 m2 is a by b, so a by b into y square minus 2h by b into xy plus x square is equal to 0. So what we get, dear students? From here we get bx square minus 2hxy plus ay square is equal to 0. This is the joint, this is also a homogeneous equation of second degree in x and y, dear students. And that jointly represents the pair of straight lines which are perpendicular to the original pair of straight lines. So that means what we can say in summary. So our given equation was what? Given equation of pair of straight line was ax square plus 2hxy plus by square. This was the given set of pair of straight lines, dear students. So after rotation of 90 degree, after rotation of 90 degree of both these pair of straight lines, both these straight lines, that means after rotation of 90 degree of this pair of straight lines, the equation what we get, dear students, is that bx square minus 2hxy plus ay square is equal to 0. and whatever is there in this one, that in the box, that bx square minus 2hxy plus ay square equal to 0 is the answer to our question. So dear students, with this I would like to conclude the class for today, and tomorrow we will be discussing uh, that pair of straight line which are not necessarily passing through the origin. Okay, and we will discuss all the relevant items. With this note, I would like to conclude the class, dear students, if unless you have any specific question for me. Okay, thank you.